Hi guys, welcome back. Last where we left is the distance and the midpoint formula. So that is where we will start off today. So we discussed gradient and now we'll look at distance and the midpoint formula. Distance formula, as the name suggests, is nothing but it will help you find distance between any given 2 points. We'll extend this example of A and B which we use for gradient. Point A was 2, 5 and point B was 6, 15. As you can see from the graph, on x-axis point A is 2, on y-axis 5, for B on x-axis on 6 and on y-axis on 15. So, between any 2 given points, if you want to find out the distance, then as the name suggests, the distance formula will come in handy. If you remember, we discussed, it's always good to mark out the coordinates as x1, y1 and x2, y2, because then on it would just be substitution into any given formula. Now if I'm looking for distance between points A and B, and if I extend the line which connects the point A and B, which connects the points A and B, and if I want to find the length of that line, right, all I need to do is to plug in the values x2 minus x1, y2 minus y1, square them up, and the whole under root into the distance formula. So for us, x1, y1 is 2, 5 and x2, y2 is 6, 15. Using the distance formula, which goes on something like this, x2 minus x1 square, which will be for me 6 minus 2 square, plus y2 minus y1 square, which for us will be 15 minus 5 square. This gives me the square of 4 and this gives me the square of 10. The whole under root, which will be 16 plus 100, the whole under root, which in turn will be the under root of 116. So the distance between the points A and B is 116, right? Or you can use your calculators to find out what will be the root of 116, right? It's going to be a little less than 11. And that is going to be your answer, which can also be thought of as the length of the line which starts at point A and ends at point B. So whether it is the length of the line which starts from A and ends at B, or the distance between the 2 points A and B, it's 116 units. Let's try one more. Let's say if we had points 4, 10, right? Let me call this as my x1, y1 now. Once again, plugging it into the distance formula, if I call this as my x1, y1, will simply mean that now x2, 6 minus x1, which is 4. y2, which is 15 minus y1, which is 10. 15 minus 10. So 6 minus 4 the whole square plus 15 minus 10 the whole square, the whole under root is going to give me 2 square plus 5 square, which is 4 plus 25, the whole under root, which is the root of 29. So let's say if I mark out the point C here at 4, 10, then the distance between the point C and B is going to be given by the distance formula, which turns out to be root 29, or 29 square root of whatever units which we are referring to. That is also the length of the line CB and also the distance between the points C to point B. Midpoint. Midpoint, as the name suggests, will help you find out the midpoint between any 2 given points. Again, extending this example, we will take the points A and B into the consideration here. Point A, which was 2, 5, and point B, which was 6, 15. The midpoint formula suggests that we add x1 and x2 with them, divide them by 2 for midpoint of x, and add y1 and y2 and divide them by 2 for the midpoint of y. If you remember, we marked this one as x1, y1 earlier, and we call this one as x2, y2. Right? So just plugging them into x1 plus x2 upon 2, which will give me the midpoint of x. This simply means it's going to be 2 plus 6 divided by 2, which is 8 divided by 2, which is 4. And then y1 plus y2, which will be 5 plus 15 divided by 2, which is 20 upon 2, which is 10. So midpoint of x values is 4 and midpoint of y values is 10, which means that midpoint between the point A and B is nothing but the point C, which will be 4, 10. I'm referring this point 2 as point C because earlier we did a sum for distance formula using 4, 10 as our point C, which turns out to be the midpoint from points A to B. Midpoint is obviously equidistant from both A to B and then B to C. Right? If you see, 4 is at a distance of 2 from 6 and 4 is also at a distance of 2 from 2. 10 is at a distance of 5 from 15 and 10 is at a distance of 5 from 5. So the x values, right, the point 4 is equidistant from x1 and x2 and point 10 is equidistant from y1 and y2. Hence 4, 10 is our midpoint. Then obviously that is a few more sums for distance and midpoint formula along with the gradient formula, which will give you a good grip over the topic, and then we can move on to equation of a straight line.